please, this is something which you have to understand. This is a like 100% guaranteed question. What is a type 1 error, type 2 error in your analytics, right? And I think I don't know whether your session or somebody from the other section was asking this question, right? So let us try to understand through an example rather than going through the definition. Then we'll come back and explain the definition later on, right? Most of you, I think, at your home or some of you personally have gone through the COVID experience, right? What they do, there are different type of antigen test, RT-PCR test. So in RT-PCR test or in antigen test, they take certain samples from you, right? So they take some nasal samples and test through some scientific method and say that whether this person is affected by COVID or not, right? In RT-PCR, it is basically rotates for certain number of durations, right? Certain number of rotations. If within the like it if it within very less rotations, they are able to find out, then you are like severely affected by COVID. So that number comes, right? CT score some 12, 10, 7, 15, 23, something like that, right? So now the point is, think we'll take two persons, right? One person is actually affected by COVID. Okay, so he is actually affected by COVID. Then he goes to the doctor, goes to the like testing center. They take a sample and test it, right? Then they found it he is not affected by COVID, right? The reality is that he is affected by COVID. But when they take sample and test it, they find that that person is not affected by COVID. So how like there also, if you see, though they do not write that for each person there is a hypothesis, but it is understood. What is the hypothesis? So think that if for a population, if I want to find out how much on an average, how many people are kind of COVID affected, right? So something similar to that. In this particular case, based on the like scientific validity, they are doing some research that whether this person is COVID affected or not, right? So what is my like if I want to test it whether this person is uh, affected by or not, right? How will I test that? If I want to frame a hypothesis, how will I test that? Just make an assumption based on what we discussed, how to frame an hypothesis. What we have discussed, whatever you want to test, that becomes your alternate hypothesis. Opposite of that becomes null hypothesis, right? So let's say in the CT RT-PCR score, right? So I think the limit is 35 per 36, right? So that vials will rotate for 35 per 36 times. I'm not sure, I might be wrong. After that, if the sample doesn't emerge that it is COVID virus is there, then they'll say that okay, that person is not affected by COVID. So let's say the limit is 35. Okay. So basically they're rotating your vials, the sample that taking, they're rotating in a machine with certain, obviously they might add certain chemicals on it. I'm not sure of that, but let's say that is the method. Then after 35 rotations, if they like kind of they do not detect the virus, they'll say that okay, that person is not COVID affected. So if this is my problem statement, how will I create a hypothesis out of it? Take the point is 35. If after 35 rotations, if the person is kind of if the sample doesn't emerge that okay, that this COVID virus is not there in the sample, then we'll say that this person is not affected by COVID. So if that is my objective, how will I say that what is my alternative hypothesis, what is my null hypothesis? Anyone make a try. So basically we are doing a scientific experiment. We are collecting nasal samples and samples from the throat. Then we are putting that sample in a chemical. Then in a machine, we are rotating those vials and these glass bottles which have that sample along with certain chemicals. Then after few rotations, that rotation, let's say that number is 35. I am not sure about that, but let's say that number is 35. If you're like about after 35 rotations, they will not check. So basically what will be my test? If the sample, if we are able to detect this virus within 35 rotations, then that person is affected by COVID. So that is my scientific experiment, right? So what will I write my alternative hypothesis? Same as my scientific experiment. If let's say number of, obviously they will be counting maybe the number of virus or number of virus strain. Let's say after with if I am able to detect virus strain less than 35 rotations, then the person is affected by COVID, right? So that is my alternative hypothesis. If within 35 rotations I'm able to detect that okay virus, I'm able to detect a virus strain, then whatever number of rotations, if it is within 10, I'll say that 10. If it is within 22, CT score or RT-PCR score is 22, 10, 12, whatever the number, right? So that is a different case. But the idea is within certain rotations, if I'm able to, because I have to stop somewhere, I'm not able to, I'm not going to rotate that or continue that research for or experiment for 1,000 years, right? So my number is 35. Within 35 rotations, if I find that COVID strain is there, that person is COVID affected. If greater than equal to 35, then I'll say that no, right? No, that person might have something else. It is not COVID, right? So that is my alternative hypothesis is if I'm able to find out COVID strain within 35 rotations. So the number of rotations less than 35, COVID strain emerged within 35 rotations less than 35. That is my alternative hypothesis. Greater than equal to 35, then I'll say that no, I think it is something else. It is not COVID. Okay. So that is my alternative hypothesis, null hypothesis. Now think about two persons. One person is actually uh, COVID affected, right? He has certain flu symptoms, fever is emerging. So he goes to the doctor and tells that okay, or carries out a test. So for that person, what happens when they carry out a test? This strain did not emerge, right? So what happens actually? H0 is false. H0 is false means what? Actually, that person in reality, I should be able to, in reality, actually, I should be able to find a COVID strain virus, right? So that means my null hypothesis is actually false, right? But what happens? I am able to kind of not able to like reject null hypothesis. That means because when I did the test and when I did carried out the test, I'm not able to find any COVID strain. That might be like sample might have been not correct, like collected accurately, or sample might have misplaced that at different regions. I'm not able to find out that. But somehow when I carried out the test, I or the chemical which I have to put, I did not put it properly. So there are multiple regions. But whatever that region, that will come back later. But when we carried out the test for that person, we did not find that person as COVID positive. So what we'll say, do not reject null hypothesis. So that means do not reject null hypothesis means that person do not have COVID. But actually H0 is false. That means that person has COVID. So whenever these kind of situations arise, some person has like certain, like your sample has certain characteristics, but we are telling that no, that sample do not have that characteristics. So that is a type 2 error, right? So that is, if I take that out, if I say that, but idea is what? Whenever H0 is false, I am able to reject it. But unfortunately, what happens here in reality? Null hypothesis is false. I should be able to reject it. But when I'm collecting data, data has been corrupted or data has not been collected properly, I'm not able to reject that. So that is where the type 2 error happens. Think about the other scenario, right? A person is not, it's normal flu, he doesn't have COVID, right? He goes for a test, right? So what happens? He doesn't have COVID. That means after 35 rotations, what should happen? He should not, that test should not say that, test should say that no, that person has not COVID. So H0 is actually true. That means that person doesn't have COVID. But what happened? Sometimes again the sample might have corrected, not collected properly, or the person who is collecting, that person might have COVID, and sometimes that strain has got there. So whatever the region is, but when they tested it after 20 rotations or 25 or 10 rotations, the symptoms show that okay, or the strain came up and said that this person has COVID, right? So in that case, what happens? Null hypothesis is, so we do not say true. Null hypothesis is reality, right? That person do not have COVID, but we are telling that that person has COVID. So that is a type 1 error. So that is nothing but that shows a significance level or level of significance. So what is that? We'll come back later. But let us try to understand what is a type 1 error and type 2 error. Type 1 error is when something, basically a false positive, right? Something is actually right, not true, right? But we are telling that false positive. That is a yes, that is true. That person do not have a COVID, but we say that that person is COVID. So that is a false positive, right? That person actually might have some different flu or different symptoms, but when he goes and do the testing, sometimes for some student or some patient that has happened. So that is where you are rejecting a null hypothesis. So always remember, our aim is to always to reject null hypothesis, right? We are rejecting null hypothesis, but actually null hypothesis should not be rejected. Null hypothesis is true, should not be rejected, but we are able to reject null hypothesis. That is the situation of type 1 error or alpha, right? Other way around is when your null hypothesis is actually should be rejected. That person has actually COVID, but due to test, we are not able to. In the test, we did not find any COVID strain, right? So we are not able to reject null hypothesis, but actually we should reject null hypothesis. That is a type 2 error, right? That is a false negative, right? So negative came, H0 is came as false or rejected, but that is actually false. That should not have been rejected, right? So this is how anytime we are doing a test and see the context, right? Which is very problematic, type 1 error or type 2 error?
Type 2 error, sir.
Okay. Anyone else? Anyone for the type 1 error? So which error do you think out of this type 1 and type 2 error is more problematic? So remember this disease example, it will be easy. Rather than remembering reject null hypothesis decision, so that is again confusing, will get confusing. Remember, there are two persons. One person actually was affected by COVID. When he goes to the test found out that that person is not affected by COVID. That is a type 2 error or false negative. The other person was actually affected by COVID. He goes to the test, carries out test, but the test found that that person do not have COVID. So that is a false positive, right?
Sir, I think type 2 error is problematic, more problematic.
Okay. So see, yes. So in this particular case, type 2 error, because what happens, that person is actually has COVID, but test found out that that person has not COVID. He might travel to outside India or somewhere else, then it will spread, or he might not take the correct treatment because doctor will say you do not have COVID, you take some other medicines, right? And he might have a health like later on something else might happen, or he might have been in a life-threatening situation later on, right? If he or she has not taken vaccine. But again, remember the context. So in this particular case, yes, because if let's say you do not have COVID, right? You might take, and doctor says this person has COVID, which is a type 1 error, right? False positive. You do not have actually COVID, but doctor or the test found out that you have COVID. So what will happen? You will get some additional medicines, which might impact your health. I'm not telling you have to take medicines without actual disease, but it will have less impact. Other way around, actually you have a disease, but the test did not show. Think about cancer or think about some very like kind of life-threatening disease. The test, if they find out that you do not have cancer, that person will enjoy his life. He doesn't worry about like taking any medicines. Later on, when it is stage 3 and stage 4, if you also find out that doctors cannot do anything, right? In a health, this kind of situation, type 2 error is very problematic, right? But think about other way around, legal situation, right? Somebody is convicted of something. If he gets convicted, he'll go to jail for 15 years, right? So in this case, what happens? Actually, he is innocent, right? He has not done that crime, right? But evidence, we found out that his fingerprints or some evidence, we found out that that person is like for that that person is convicted. Now that person will go and suffer for 15 years. So remember, when you talk about the impact of this error, we have to remember the context. So based on your data, if you say that that person, or the evidence you say that that person is a thief or a murderer, he might get a death penalty also, right? That is irreversible. So once done. Now what happens? That person will get convicted for something he has not done. But other way around, that person actually has done a crime, and your evidence what you have collected, that is not sufficient, or that is not enough to say that that person is a murderer or a. So I'm not telling that is good, but at least it is, if I compare these two. So that's why our law system is do not it might be a possibility that some corrupted individuals, some murderers, thieves might get away with the system, but we should not kind of punish a innocent person, right? And that's how almost all the kind of countries law system puts that much effort in collecting correct evidence. Because otherwise, think the situation, if it is about a death penalty, that person has actually not done a crime, right? But who collected evidence, and it shows that that person is convicted and he gets a death penalty. Other way around, it might what might happen if I talk about the type 2 error, that person is actually serial killer or murderer, right? But we do not have evidence, right? We are not able to convict that person. I'm not saying that is a good thing, but at least I'm not punishing an innocent person. But in a health situation, when we are taking certain treatment which will benefit us, benefit the person, type 2 error becomes complex. So you have to remember the context on which you are comparing type 1 and type 2 error, right? Is this part clear or any doubt?
Sir, then how we can control these errors, type 1 and type 2 errors?
How do we?
What are the ways to, sir, control, minimize that error, sir? Type 1 and type 2, because
Okay.
in
Yeah,
yes.
correct. So the point is, can I avoid all these two errors? So answer is no. Errors will be always there. Like I said, because remember the situation, we have 10 crore, 120 crore, 140 crore of India's population, right? When I'm collecting data for a particular thing, let's say how many people use my product, or how many people are have vaccinated, and all those things, right? The best way is to collect data from everyone, right? So that is the ultimate weapon, ultimate thing which you can do, which will remove all these errors. But we do not have time, we do not have effort to collect from the all the data from population, right? So maybe in 10 years, every 10 years we have the census for that, but not always, not every time we are going to do that. So to answer your question, whether we can eliminate these kind of errors, completely no. These errors are going to be there. So the question is how to minimize that, or how to accept that, right? So this is what known as type 1 error is alpha, or level of significance level. It is different than confidence level. I'll discuss that. So alpha means how much error in your study you are accepting. So this type 1 error, you know that it will be there in your study. Now the question 2 is that how much error in your study you are able to accept. So in this particular case, when we are doing a health one, we might say that okay, 5% is okay, right? 5% error should be okay, because then the question is why you are not taking 99%. If you say that okay, 100%, there will be some error. 99.99% accuracy, so alpha will be 0.0001, right? Problem is, as your alpha level decreases, or the level of significance decreases, the number of samples which you have to take to have that kind of confidence increases exponentially. That means you have to take a very large size sample, which is not actually possible in a real life scenario. So think about your SIP condition. If you are doing for a bank, that bank has 5 crore customers, how many customers you can do a survey? Maybe 300, 500,000 maximum. But if I go and start saying that you have to have 99.99% confidence, you might have to collect data of 1 lakh customers or 50,000 customers. When you calculate that, I hope the sample size calculation have been concluded. If not, we'll discuss that in maybe one session. That is a formula which will help you to calculate the sample size. And what happens in that formula? As your alpha becomes smaller, your sample size becomes larger. So one way to obviously you mentioned, or your question was how to reduce the error. One way to increase your sample size, but again there is a limit, right? If we have that much time and effort to collect all the samples, we can go ahead and collect the population itself. So that is somewhere we have to like put a line that okay, how much sample data we can collect, and accordingly again it is a both the things you have to consider. For your study, if you do 5% mistake, is it okay? Or you have to say that no, I have to be 99% confidence, that means I can do only 1% mistake. Remember that mistakes will be there, and it is not that mistakes in data collection. Mistakes can be from anything, right? Sample can be corrupted, you have not collected sample correctly, the person who is providing you data, he just provide you wrong data, right? So there can be multiple reasons which you will not be able to control. But you, what you can control, that how much error you can accept, right? Whenever you are carrying out a study, you will say that. So what does it mean for you, right? So whenever we are doing a study, we know that okay, we are taking some sample and making a judgment about our population. How much confident I am on my study, right? If I say that my alpha level of significance is 5%, what does I'm actually saying? 100 minus 5%. That means I am, my confidence level on my study is 95% of the times. In other way around, what I say that if I do this similar study in other states, other countries, somewhere else, 95% of the times I'll get the same result, right? So alpha is level of significance or significance level. 100 minus alpha is confidence level. So when I say that alpha is type 1 error, the error which I am accepting in my study, right? Other way, what I'm saying, how much confident I am on my study, 100 minus that, 100 minus alpha. So whenever you look about research paper or somewhere, they will be telling, so at a 95% confidence level or 99% is confidence level. So I'm carrying out a study at 99% confidence level. Other way of saying that I'm accepting error of 100 minus 99%, that is 1% alpha. So whenever you are doing your any kind of research project, you have to mention your alpha, your type 1 error which you are accepting in your study. So that is around 1%. Sometimes, most of the times it is 5%. Sometimes, like I said, when you know that the criticality of type 1 error, you might take 1%. Sometimes you can be little bit like relaxed and say that 10%. But generally these are the three numbers: 1%, 5%, 10%. Most of the times we take 5%. What is the reason of 5%? No reason. People started taking 5% of the time, almost all the research for 60 years back. So everybody started continuing. Whether I should take 10%, 1%, 5%, that is up to you. So you'll say that why not 7%, why not 3%? You can take that. But again, it is basically a tradition of taking 5%, right? So it is not that you cannot say that 3% or 4%, right? You can take, I'll say that I'll take 3%. Okay. So this is the point is your research will have always some error, but how much error you can tolerate, that you have to mention in the beginning. And according to that, you have to collect sample, you have to calculate sample size, and that many sample you have to collect. When I say sample, your sample size, not that you are collecting multiple samples, that we are very clear. You are collecting in a cross-sectional study one sample consisting of how many data points. So that is your sample size, right? So that is how you, and then the type 2 error, there is no actual kind of way to minimize type 2 error. It, so like in each step, how much robust design you have. So you have to train your persons who are taking interviews or collecting questionnaire. Your sample has to be randomized. The sampling method, if it is a probabilistic method, if you're taking a random sample or stratified sample, that helps in reducing type 2 error, right? But there is no kind of how much percentage, there is no answer for that, right? So only thing is that you can have to control on that. You should be like create a robust research plan to minimize type 2 error. Type 1 error, you have to mention in your research. Okay, I am accepting 5% error. My alpha or level of significance or significance level is 5%. That means 100 minus 5%. That is 95%. I am confident that if I repeat this research, I did this research in Odisha, if I did this research in a different sample, I'll get the similar result. Last class, you remember we did this hypothesis creation for educational loan, for this farm loan, right? So what we are doing, we are collecting sample from 100 farmers or 200 farmers. Then we are saying that, okay, this is the result I get. The average loan amount is less than some 1,04,000, right? So when I say that I have a 95% confidence level, what I'm meaning to say that if I carry out this study again with a different sample within Odisha, 95% I'm sure that I'll get the similar result. There might be some time 5% error, because these are the things I'm accepting. There might be issue with my data collection, issue with the way people have answered, right? So those kind of things will affect my study, but that I'm telling you in the upfront that will be limited to 5%. So that is your alpha level of significance or significance level. Clear? Clear or any doubt?
Yes, sir. Yes, sir. Clear.
So sometimes we'll look about something called confidence interval. It is not confidence level. So there are two different concepts: confidence level and confidence interval. But first, you have to define your confidence level. Confidence level, like just imagine the easier ways to remember that you do a test, you give cat, math, and all those things, right? So generally, what people ask, how much you will score. So you say that, okay, I'm very pretty confident that, okay, I'll score 50, 60, 70, or whatever you imagine, right? Whatever, like what you have done your test, right? So you are giving a that confidence. You how much confident you are that, right? So similarly for your research study, how much confident you are in, how much confidence that, okay, you'll get this kind of result. So I'm 95% is confidence. So my confidence level is 95%. So what does it mean? There is a 5% chance that I might have mistaken. I might say that, okay, I'll get 60, but there is a 5% chance that I might get some other scores. Same thing here. Type 1 error, when I say that, that is the situation where there might be certain like kind of data point, which is like kind of I should have like kind of uh, when I'm collecting data, there might be certain issues with the data collection, or the data itself is corrupted. So there can be multiple errors. But I'm saying that, okay, all the errors combined limited to 5% error, right? Which will give rise to something called false positive. That actually was not kind of true, but I say that that is true, right? And when we talk about confidence interval, what we say, from the sample data, when I'm calculating any, let's say, mean, average, right? So at the end, what I'm saying, okay, whether this is greater than something or less than something, can I know that where actually my population mean will lie? Think about the last class example of what we are studying. So I'm taking like kind of 350 students, or the like kind of like, let's say, your internal evaluation. Out of that, I take 30 students mark and trying to assume that, okay, what will be the average score, whether it will be greater than 3, 4, or 5, something like that I want to test. So that is one way to do. So that is hypothesis testing. Confidence interval will be required when we are doing some interval estimation, prediction, right? So when you go to the next year, when you do this kind of analytics course, most of the times we are predicting something, right? So the question is, in that time the hypothesis testing will not come picture. So the question is that, okay, so you have collected a sample. Where do you think that, okay, your if I talk about all those 350 students, where their average marks will lie, internal evaluation, where will that average marks will be there, right? So if I want to predict something for my population, some numbers mean the mean score or the mean satisfaction score, mean amount they spend in shopping, mean number of items they have in their shopping cart in Amazon or Flipkart. If I want to predict all those 5 crore or 6 crore customers, that is where I'll need my confidence interval. What does it mean? Whatever sample I have found out. So let's say Amazon is carrying out a study. So they want to understand on an average how many items people put in their wish list. Because when they're writing that web algorithm, they have to put a limit, right? It should not be that one person is putting 5 lakh items, all the items, whatever he sees every day, he put in the wish list. So whenever you are designing a website, you have to put a limit to that, right? And that is what Amazon wants to understand. On an average, how many numbers people want to keep in their wish list, right? So I go out and do the survey from 1,000 Amazon customers. So different customers from different background. So I do that randomization and find out answer. Some people say 10, 15, 30, like that, I get that number, right? But what I'm doing, I'm collecting that number and trying to predict it for overall 5 crore or 50 lakh customers of Amazon, right? So how will I predict for the population, right? So there I'm not hypothesis testing. I'm not saying that okay, average number of the like average cart size or the number of items in a cart of an average customer is greater than 10 items or greater than 5 items. If my objective is to find out that only, that is hypothesis testing. But generally, what a company wants to know, on an average, how many items people will keep their in their website whenever somebody is visiting Amazon or Flipkart. On an average, how many items people in their cart? How many items people put in the shopping cart, right? So in that case, what will happen? I have collected data. I collected 500 or 1,000 customers data. Then whatever mean I get, let's say I get a mean of 10, right? So for that 1,000 customers, 10 plus minus critical value. So that I'll show you how to find out that critical value multiplied by, this is the standard deviation of the sample, right? Let's say the standard deviation I get as 2 divided by square root of n. Square root of n is number of sample, sorry, sample size, right? Number of, not number of sample, number of your sample size, number of data points. Let's say I've done it for 1,000 customers or 10,000 customers, right? So take 10,000 customers, square root of 10,000 is 100, right? And let's say if I got this S is 2, so mean is 10, average number of items people put in their cart is 10. 10 plus minus this value, I'll show you how to find out, multiplied by 2 divided by square root of 10,000, that is 100. 2 divided by 100 is 0.02. Let's say this is, let's say I'll show you how to calculate, but let's say this is 2. 2 multiplied by how much? 0.2002, 0.0004, some point like that. So what happens? Your population mean will lie somewhere between 10 minus 0.004 plus 10 plus 0.004, right? So what I'm saying, when Amazon is designing, so they will keep within that range, right? In this case, I've taken a larger sample, my standard error, that's why it becomes very smaller. So standard error, just see that, okay, how your estimate will vary. If let's say rather than 10,000, I have taken only 100. So what will happen? 100, then this is square root of 100 is 10. Then S is 2. 2 divided by 10 is 0.2. 0.2, let's say critical value is 2. 2 multiplied by 0.2 is 0.4. So 10 plus minus 0.4. That means your population, if I talk about whole population, on an average, their number of items they put in their cart will vary from 9.6, 10 minus 0.4, 9.6 to 10 plus 0.4, 10.4, right? So that is how we utilize confidence interval to make certain prediction. So it generally we do not use that in our hypothesis testing, because hypothesis testing for some statistical inference. But why I'm showing you that, sometimes the question comes, what is the difference between confidence interval and confidence level? So the answer is, confidence level is how much confident you are on your study that will repeat the same answer in different samples, right? If I'm finding out that, okay, Amazon, so this number, what I got, the mean number of items people in their put in their cart is 10. If I do it anywhere in the India, 95% of the times I'll get similar answer, right? So that is my confidence level. When I talk about confidence interval, so you are talking about a sample, then what about the population? Where actually the population mean lies? So it will be somewhere between 9.6 to 10.4, right? On an average, it can be anything between 9.6 to 10.4. So we need this confidence level. So when you talk about critical value, it depends upon, to find out critical value, we need confidence level. So without confidence level, we cannot calculate confidence interval, right? So this has to be defined first, confidence level, then only you can find out confidence interval, right? So any questions on these three concepts, type of error, your confidence level, and confidence interval? Any questions, any doubt?
So confidence interval is done for the population and confidence level is done for the sample, right?
No, confidence interval, actually we're doing calculate because we do not have the population data, right? We are calculating on the sample, but we are making a prediction. It is used for making a prediction. Where does your population mean will lie, right? See, at the end, what we are trying to find out for any kind of prediction. Let's say if I say that, okay, how much India will score in next, let's say, World Cup on an average, right? I do not have that is I'm predicting something for next World Cup, but I have the data of last whatever sample, whatever last number of World Cups has happened. For each match, I'll take those score. From that, can I predict something for my? So how much score? I cannot exactly predict on an average whether it will be 200, 500, 350, 300. That I cannot exact number I cannot say, but I can say that they'll score something between somewhere between these to this, right? 210 to 350, right? So how will I calculate that? Based on a sample of data, whatever I have data available right now. Using that, I'm trying to predict for the something for the population, overall population of number of World Cups has happened, right? Same thing here. Let's say the what other example we take? So let's say think about this. Your all of you are interested in how much CTC people get, right? How much average package size. For each individual, I cannot predict, but on an average, I can say that for your batch, what will be your average pay package? But exactly, I cannot say that okay, it will be 6.2 or 7.2 or 8.2. But based on the past data, I take that data, I take the mean based on my confidence level. I can predict okay, your average salary package might be somewhere between 6.5 to 7.5 or 6.5 to 8. So that is how confidence interval helps. For that, again, I need this critical value, and critical value is dependent on your confidence level. Because this 6.5 to 8, when I say I am how much confident I am on that range, I have to tell that because I cannot predict with 100%. If I'm able to predict with 100%, I'll become somewhere like the most wealthiest person in this world, right? Because I can predict anything. The point is, when I say that okay, your average salary package is 6.5 to 8, how much accurate I am, how much confident I am. So I have to say that okay, 95%. When I say that my confidence level is 95%, based on that, I'll find out this critical value PC, and based on the sample, let's say I have past data of your all these CTC package. Let's say right now the average salary package is 6.5, right? And standard deviation is 1, right? All those last 10 years of data, if I take, standard deviation is let's say 1 lakh, right? So 6.5 lakh, this is 1 lakh, and I take a data of let's say uh, 9 years, right? Last 9 years. I'm just taking that number because square root will be easy. Or last 16 years, right? So what happens right now? My average salary package for that last 16 years when I take, the average is becoming, obviously it will be a little less because 16 years I'm taking, let's say it is 5.5 or 5, right? So mean of sample becomes 5 lakhs plus minus, let's say how to find out this number I've not shown you, I'll show you later on how to find out critical value. My standard deviation of all these data points, let's say it is 1 lakh. So mean is 5 lakhs, standard deviation is 1 lakh. I have taken data of 16 years, 16 batches of MBA student, square root of 16. So what happens? 1 lakh divided by square root of 16 is 4. 1 lakh divided by 4 is 25,000. Let's say this critical value is 2, right? 2 multiplied by 25,000, 50,000. So if my mean is 5, so what I can say that 5 minus 50,000, that is 4 lakh 50,000, or 5 plus 50,000, 5 lakh 50,000. So what will I say? With 95% confidence, I can say that the average CTC level will be between 4.5 to 5.5. Then you'll say that, sir, how you can say that because last 3 years or 5 years, people are like average salary package is 6.5 or 7, right? So then what becomes? Then what happens? Because I've collected data for the past years, right? And I have not taken the rupee inflation, right? Because the person who was getting 4 lakh salary 10 years back, that if I take the inflation, that same salary will become 6 lakhs. So that is the error in my data collection, right? Because when I'm considering rupee value, I have to consider because I'm predicting for future. Rupee value I have to consider on the future money. What will be the future value of that money? That 4 lakh 10 years back is not same as 4 lakhs today, right? So that is a problem with data collection. But if everything is correct, that will be your salary package, right? If let's say that I have considered already, then that will become your range of salary package. But I'm not 100% sure. I'm only 95% sure, right? So that is how confidence interval helps us to make prediction about the population, right? Which we have not predicted. Clear or any doubt?
Yes, sir, clear.
So now comes most important concept of p-value, right? And most of the times you will get confused with this alpha level of significance and p-value, right? Let us try to understand what this is. Try to read it and we'll try to understand what does it mean. P-value is the probability that the chosen test statistics, right, would have been at least as large as its observed value if every model assumption were correct, including test hypothesis, right? So why I have underlined it has a meaning. I'll come back to that later on. But this looks like a very historic, very strange, or very difficult statement. Let us try to understand it simply. If my null hypothesis is true, and I have collected data correctly, I have robust design, I have taken data random sample, every assumption is true, and my null hypothesis is true, right? Then p-value is the probability that the chosen test statistics would have at least as large as observed value, whatever value I am collecting, right? So this is what this, if you remember, this is a sampling distribution and this is a probability distribution. Probability distribution, how you frame? In the x-axis, there will be certain random variable numbers. Let's say this is your quiz marks. So this some numbers will be there here, and this is the frequency, right? The probability of getting that quiz mark, right? So and this is what we have discussed will be bell shaped, right? So that will be close to like not, if not necessarily full normal distribution, close to a normal distribution, right? This is a sampling distribution, again not a sample distribution. So what I'm saying, and I have told you that we are not going to create a sampling distribution. Already mathematicians, statisticians have created for us. We are going to use that. Today I'll show you one sampling distribution, that is a T distribution. So using this distribution, so what does this distribution mean? If your null hypothesis is true, right? Observed value is whatever my statistical significance, right? So I get this whatever value. Let's say we'll try to look through one example. Let's say I want to understand whether my mean quiz score is greater than 3.5. Okay. Then I, like when I take a sample, I get some score of 3.6, right? 3.6 or 3.7. I take 30 students, I get a score of 3.6. Now I want to understand for the population of 350 students whether it is actually greater than 3.5. If I just go by the sample, yes, I got an answer of 3.6, 3.6 greater than 3.5. What kind of statistical test, right? But that is not true way. That is not the correct way, because we have just taken 30 students, right? They might not represent all those 350 students. So how should I ensure that the number what? Because 3.6 obviously greater than 3.5. And what else I'm calculating? So what I'm trying to calculate is that whether this answer will remain true for the overall population, right? So that is where we calculate something called test statistics. So there are different ways to calculate test statistics. We'll go one by one. The very simple way is that whatever is your observed value, right? Don't remember the formula in different calculations. Remember the theory. Observed value, whatever value you observe minus expected value. I'll show you the formula later on in the slide. Divided by standard error, right? Observed value minus expected value divided by standard error, right? So that calculation will come back later. Don't worry about that. So that is the theoretical value of a test statistics. So I calculate that. Let's say that number I got some number 0.2, 0.3, or 0.4, right? So in this sampling distribution, which is a T distribution or normal distribution or a Z distribution, right? What I'm trying to find out in this number line, where does that number will come from? Where does this number will lie, right? So whether it will lie in this region or it will lie in this white region, right? If it is lying in this dark blue region, right? So I can say that I can reject my null hypothesis. I can say that yes, the average quiz marks will be greater than 3.5. But if it is lying within this, right? So I will not be able to reject, right? So this, whatever my alpha value I take, right, whatever my error value I take, that gives me something as confidence level. If I take my error value as 5%, I have a 95% confidence on my study. I'm 95% sure is that my study is correct. So this, on that 95%, when I say that 95% with certain some other parameter degrees of freedom, I'll show you that. That gives me critical value. Let's say this critical value for this study is 1.6, right? So critical value is here. So when I say that, okay, I get that test statistics is 0.4, where does this 0.4 lie? If it lies to the left side, I'm not able to reject it. If it lies to the right side, I'll be able to reject it. 0.4, obviously, if I talk about the number line, 0.4 will be in the left side of 1.6 or 1.8, right? I'll not be able to reject it. But let's say I get a data of 1.8 or 2.8 or 2.3. 2.3 is greater than 1.6. Then I'll say that I'm able to reject it. So that is one way to carry out your hypothesis testing. Other way to do the hypothesis testing is to, whatever your test statistics you find out, 0.0218, 0.5, 0.3, whatever test statistics you find out, you try to find out if your test statistics is true, if your null hypothesis is true, what is the probability of finding a test statistics as large as that number, right? So this statement says that if I believe is that my null hypothesis is true, what is my null hypothesis? If I say that I want to prove average score is in a quiz is greater than 3.5, what will be my null hypothesis? Less than or equal to 3.5, right? So if I believe my null hypothesis is true, that means average quiz marks is less than or equal to 3.5. If that is true, what is the probability of getting a test statistics of whatever I have got? I have calculated my test statistics. Let's say it is 0.218. What is the probability of getting a test statistics of 0.218? If that p-value, let's say, came as, probability value came as 12%. How to calculate that? I'll show you in Excel. If that probability came as 12%, right? So that shows that there is 12% chance that your null hypothesis is true. But what I have told in the beginning, I'm taking a confidence level that I'm 95% is true, 95% is correct. That means I can be mistaken by only 5%. But now what my study shows, there is a 12% chance. There is a 12% chance that your this marks can be less than 3.5, can be less than or equal to 3.5. Then I cannot reject the null hypothesis, because then this is a very good probability, right? 12%, which is greater than 5%. I have put that line as 5%. But let's say your this p-value of getting a score of 0.218 becomes 3% only, 0.03 only. Then what do you show? What you say? Getting this number is very rare. That means yes, it might be greater than 3.5. Think about in this way. I'll try to explain through a different example. Average height in India for males are around 5.8, right? So it is not that we are measuring everybody, every individual, right? It is not that 140 crore or out of 140 crore, let's say 60 crore male or 70 crore male. Out of that, obviously, if I take out children and elders, those who are not able to move, let's say there are 50 crore male who are able to walk, right? So it is not that I'm going to measure the height of 50 crore individuals, right? So now let's say I have a hypothesis that, okay, the average height is greater than 5.8 inches, right? Then what will be my null hypothesis? That is what I want to prove, greater than 5 foot 8 inches. Then what will be my null hypothesis? Average height is less than equal to 5 foot 8 inches. Obviously, I'm not going to collect height of 50 crore Indians, right? Male Indians. I go and randomly from different states, I take some sample for 5,000 or 10,000 male Indians, male between, let's say, 18 to 50-year-old. I take their height, right? Then the average came at 6 foot 4 inch. And I say that all my sample collection, everything is correct. It is not that I've gone to a basketball team and I have collected there, or I have gone to the Himachal Pradesh or northern Kashmir. I have taken those people's heights only, right? I say that I have a robust research plan. I've gone to all the states, randomly collected sample of male Indians. Then when I'm measuring the height, it came as 6 foot 4 inches. So what does your intuition say? If I've conducted my study correctly, if average height is 5.8, and when I like kind of get an this average height, when I said that less than, or my null hypothesis is less than equal to 5 foot 8, but I'm collecting a sample and getting a data of 6.4 inch, then what your intuition says? Forget about your statistical test. What will say that if everything is correct, no, it should be greater than 5 foot 8 inch, right? Because how can it be that okay, I'm getting a average of 6.4 inches? Everybody understand what I'm trying to tell you. So let's say I have a 50 crore Indian population, like male population, right? Some earlier study have said that the average height of Indian male is 5 foot 8 inches, 5 foot 6 inch. But right now, if I do that study and collect data of 10,000 Indians, Indian males, and I get a height of average height of 6 foot 4 inch, and I say that I know that for certain that my study is correct. I've done all randomization. I have done collected data correctly. I have gone individually to measure the height. So there is no issue. It is not that I have asked the people and they applied. So I have in the same measurement scale, I have measured the height and I get a 6.4 inch data. So what your intuition say? Whether your average height will be greater than 5.8 or less than or equal to 5.8?
Greater than.
Greater than, right? So that's it. That is only we want to trying to find out. So what will say? What is the probability of getting that 6.4 inch? If I say that my null hypothesis is true, what is my null hypothesis? Null hypothesis average height is less than equal to 5.8. If my null hypothesis is true, what is the probability of getting a height of 6.4 inch? If the probability is very small, then what will say? I can reject null hypothesis. Null hypothesis is not true. But the probability is very high. That means whatever my null hypothesis must be true, right? Then how do you decide to what is high probability, what is low probability? That is where your type 1 error or alpha level of significance helps. Whatever number you have fixed, 5%, 10%, 1%, if your probability of getting that 6.4 inch in your sample crosses that, that means null hypothesis is true, right? If it is less than that, it is a rare event, right? Null hypothesis might be wrong. Then you say that okay, with 95% confidence, we can say that the average height is greater than 5.8 inch, right? Then the question is, why you didn't take 6 feet? Because I did not have data, because earlier data says that 5.8 inch, right? So after taking data, I cannot change my hypothesis, right? Because I got a data of 6.4 inch. Now I'll say that can I test it for 6 feet? No, not like that. So the point what you have taken to test is 5.8 inch. Accordingly, I have collected data and carried out this study. I can guarantee say that with 95% confidence, the average height is in 2022, when I measure, it is greater than 5.8 inch. So what does again the p-value means? Whatever you data you collect. So here I collected data and got a average height of 6.4 inch. If I believe that my null hypothesis is true, that means the average height is less than equal to 5.8 inch, right? What is the probability of getting a value as large or greater than 6.4 inch, right? If that probability is very high, right, mean null hypothesis is true. If probability is very less, null hypothesis is wrong, null hypothesis can be rejected, right? So whenever we are doing a hypothesis testing using this method, we are believing our null hypothesis to be true, and we are trying to find out if null hypothesis is true, then what is the probability of somebody getting this amount of mark?
Sir,
Yeah. Yeah.
sir, but if the probability is high, then we should say that the average height is greater than 6 feet 4 inch. Then why we are taking the null hypothesis is true? Because in the null hypothesis we are taking it the average height is less than 5.8, right?
Correct.
So then why
So
we are taking that
the
null
probability of
hypothesis?
what? The probability of getting this null hypothesis. So the what we are trying to do with hypothesis testing, we're trying to reject it, right? So our aim is not to prove null hypothesis. Our aim is always to reject null hypothesis. Remember, We are doing
Yes,
through
sir.
a null hypothesis, but our aim is to reject null hypothesis. It is not that I'm trying to prove. And what is my null hypothesis here? Null hypothesis is less than 5.8 inch or less than or equal to 5.8 inch. If I get a 6.4 inch, that probability is very high. Then what it means? Null hypothesis is true only. So what does it mean? Yes, it can happen. It is highly probable that if your average height is 5.8 inch, you can get a sample of 6.4 inch. It is highly probable. Then I'll say that yes, null hypothesis is true. But when you say that if your average height is less than equal to 5.8 inch, probability of getting a 6.4 inch is very less. Then average height is actually not 5.8 inch. It can be more than 5.8 inch. Think about the other example what we studied, what we discussed in the last class. In your glass box, there are different these chocolates, right? White, pink, and all those chocolates. One of your friends says, "No, no, now this chocolate company has started only black color, right? No pink, no red, no yellow. So Cadbury Gems only coming is black color." And so you take different sample from, you go to different stores, you collect different this Gems chocolate, put in a big large glass box. So direct you collected these samples, right? Now you put your hand, take a bunch. So you, what your friend is telling, that every color right now is black, there is no other color, right? So if that is true, but what answer you are getting in your the sample, what you are getting is, let's say there are a mix of red, pink, yellow. So what does it mean? That means your friend is not telling true, right? There are other colors. That means the chocolate company has not changed the strategy. There are different colors. Same thing we're utilizing in this study also. How I want to understand whether the average height, or I'll take a different score, a different somebody comes and tells you that your senior batch of students average package is greater than 20 lakhs, right? So what will say? Arey, how can it be possible? Last 5 years, it is 6.57 around. Suddenly you come back and tell that 20 lakhs. That is what you want to prove. That is your alternative hypothesis. Average pay package, average CTC, this batch, your senior batch is greater than 20 lakhs. Then what will be your alternate hypothesis? Sorry, what will be your null hypothesis? Less than equal to 20 lakhs, right? So you framed a hypothesis. Now obviously you cannot go to all the 350 seniors or 250 seniors who have been placed. So out of that, randomly you collected data from 50 seniors, right? So what is your hypothesis? Null hypothesis is less than equal to 20 lakhs. Alternative hypothesis greater than 20 lakhs. Let's say hypothetically, when you get a number, those 30 student or 50 student whom you interview, when you do that survey, you got an answer of 30 lakhs. Average salary package of 30 lakhs. What will you say? Going without going to a statistical test, what will you say? Yes, it might be true. It might be greater than 20 lakhs, right? Yes or no?
Yes, sir.
But if you get, let's say 6 lakhs, 7 lakhs, what will be your assumptions? It cannot be greater than 20 lakhs, right? When I'm getting a sample of 6 lakhs, I go talk to my seniors, and when I ask about their average salary, when I get an answer of 6.5.7 lakhs, then what will I say? No, it cannot be greater than 20 lakhs, right? So that's it for what we're trying to find out here. So what will you do? You'll go and ask your seniors about their salary package. Each one of them tell their answers. Then what you'll find? Let's say it is actually 7 lakhs, right? So now what you are trying to study? If your null hypothesis is true, your null hypothesis is less than equal to 20 lakhs. What is the probability of getting an answer of getting a sample of 6.5 lakhs or 7 lakhs salary package of average salary package of 7 lakhs? If the probability is very high, let's say you get a p-value of 0.6, 60% probability that yes, it will be 6.5 or 7. Then what happens? Null hypothesis is true, right? It is less than equal to 20 lakhs. But let's say you get a probability of 0.03, 0.02, that means 2% only. That means null hypothesis is being correct is only 2%, right? Then probability is very less. Then you will go by the alternate hypothesis. Because if you believe that your average salary package is less than or equal to 20 lakhs, and you are getting that probability of null hypothesis being true is 2% only, 3% only, which is very small, then you might say that it is greater than 20 lakhs. Yes or no? So when you talk
Yes,
about
sir.
the probability, it is about the probability of null hypothesis being true. Whatever data you are collecting, probability of null hypothesis being true.
Yes,
Anyone
sir.
else? Yeah, anyone else having any doubt? Because this is something we have to understand very clearly. Later on, believe me, it will help you a lot. Standard questions about these 2 pages only. Type 1, type 2 error, p-value, confidence level, confidence interval. If this part you are clear, other things, it will not take more than 3-4 hours. So probable p-value is if I understand my null hypothesis is true, if you believe that your average salary package of your senior batch is less than equal to 20 lakhs, then you go and collect data and you found out that all those samples randomly you collected, they are telling that they're getting 30 lakhs. Then probability of that happening will be very small, right? It can never happen that 50 students you ask and for them the average salary package is 30 lakhs when the whole batch is less than equal to 20 lakhs. It is very rare event, right? So that's why you'll say that yes, null hypothesis can be rejected. Because if I believe that null hypothesis tree, getting this small probability will be very rare. Any questions, any doubt on this? So this part I guess we have discussed. So what I want to show, what is a critical value, right? So to find critical value, there are two things you have to find out. One is sampling distribution, whether normal distribution, chi-square, F distribution, T distribution, that for different tests, like when you do one sample or a two sample test, we will be using a T distribution. When you are doing a cross tabulation, we'll be using a chi-square test. When you are using this regression, ANOVA will be using a F distribution, right? So that part I will discuss later on, what type of sampling distribution and why. But remember that we are going to use a distribution, right? Distribution means a statistical table. And we want two other factors, degrees of freedom and what is your alpha value, right? What is your level of significance or significance level, right? Then with that, we'll try to find out our critical value, right? Uh, if a right tail test statistics, whatever you find out, if you greater than critical value, you'll be able to reject null hypothesis. Left tail test statistics is less than the negative of critical value, you can reject null hypothesis. Two tail test, absolute value of test statistics greater than critical value, will be able to reject null hypothesis. Don't worry about that. When again, don't remember these steps, right? Don't remember it as a formula, it will be very difficult. When I actually show you that in Excel, again I will explain that to you how actually we are doing. So don't worry about that. Only thing what we are trying to find out, or you have to take from this slide is, this is your distribution, assuming your null hypothesis is true, right? This is a two-tail test. So let's say I want to understand whether your average salary package, generally two-tail test we do not do, and the reason being, let's say I want to understand whether salary package is 6.5 lakhs or not, right? My alternate hypothesis is salary package, average salary package is not equal to 6.5 lakhs. So when I say not equal to 6.5 lakhs, it can be either less than 6.5 lakhs or greater than 6.5 lakhs, right? So if my null hypothesis is true, whatever data I get, whatever sample I collected, it will fall here. So that is non-rejection region. Non-rejection of what? Non-rejection of null hypothesis. So whatever value I collect, it will fall here in non-rejection region. If it is falling in this red region, right, that means non-rejection region, right? This is non-rejection region. Reds are rejection region. How to find out that? Let me show you through an example. Okay. So my research objective is those to understand whether average marks scored by student in BRM quiz is greater than 3.5, right? So and what I'm testing, to testing at 95% confidence level. So this is confidence level. Okay. So I want to carry out this study at a 95% confidence level. What does it other way means? Alpha is 5%. Alpha is, that means I'm accepting a error of 5%. My study can be wrong 5% of the times for a sample size of 30 students. So what I do, I go and conduct a quiz of 30 students. I get a sample mean of 3.6 and standard deviation of 1.97. With this information, what I want to say. So before that, what will be my alternate hypothesis here? Greater than 3.5. Average marks scored by student in BRM quiz is greater than 3.5. What will be my so what we have discussed, whatever your objective research objective, that becomes your alternate hypothesis. What is my research objective?
Yeah,
To check,
we score better than 3.5 is my research objective.
Average marks in BRM quiz is greater than 3.5. Mu, that is population mean, right? Population, that means 350 students. If I actually take a quiz, the average marks will be greater than 3.5. Then null hypothesis will be less than equal to 3.5, right? So when I actually take a sample of 30 students, I get this number. I calculate my mean and standard deviation. Now the question is, by using this data, how to prove this? How to say that whether my alternate hypothesis is true or not, or I can reject this. If I reject it, that means this is true, alternate hypothesis is true. So what I said, we start with believing that null hypothesis is true. So we say that, okay, imagine that null hypothesis is true. Now we calculate something called test statistics. So the formula of test statistics is whatever your observed value, how much value you observed, 3.6 from the sample data, minus expected value. What is my expected value? I'm expecting 3.5. That is what I want to test, or my test value, right? Observed value minus expected value divided by standard error. The formula of standard error is your whatever your standard deviation divided by square root of n, right? Square root of, because I am taking 30 students, right? So total, if I add the frequency, that is 30 students, right? So 1.97 divided by square root of 30. So 0.1, 3.6 minus 3.5, 0.1 divided by 0.359. So that gives me rise to a test statistics of 0.278, right? So now the point is, remember what we discussed in the previous slide. If I believe my null hypothesis is true, there are two ways to do this hypothesis testing. I will try to find out the p-value or the probability of value of getting this number 0.278. So that is one way. Trying to find out p-value, compare that with your alpha. Alpha is 5%, and say that, okay, whether it is less than 5% or greater than 5%. Less than 5%, you go ahead and reject null hypothesis. That means, yes, it is possible that it is students will score on an average greater than 3.5 marks. Other way around, which I'm trying to show you, is a critical value. So what is a critical value? If you believe your null hypothesis is true, that confidence level or significance level, what you are taking, that 5%, where does that number lie, right? So how to get that? So if you like, I'm not sure whether you are able to see this clearly. Let me just make it a little bigger. So what we're trying to find out, if I say my confidence level is 95%, my alpha becomes what? 100 minus 95%, that is 0.05 or 5%. So when I'm trying to find my critical value, I have to use certain table, that is, in this particular case, it is a t distribution or a standard t distribution. What is that? And all those things will go one by one. Don't worry about that. So I need alpha, I need something called degrees of freedom. So again, there is a calculation or there is understanding of degrees of freedom. For t distribution, remember the formula, that is sample size minus 1. So if you have 30 students, so your degrees of freedom will be 30 minus 1. So I'll come down here, I'll go back to this number of 29. 30 minus 1 is 29. Then I'll look at alpha at 0.05. So whatever the number is here, in a row wise, I'll go to 29. Why 29? My degrees of freedom is 29. That is sample size minus 1. So I get 29. Then I look at a alpha value of 5%, 0.05. Why 0.05%? Because I'm telling I'm 95% confident on my study. That means there might be a 5% error. So when I come down here at 0.05 and 29, I get a number of 1.699. 1.699 or 1.7. So now what I have to say that whether my test statistics lies where, if my null hypothesis was true. So if I go back to this, if my null hypothesis was true, right? So look at this right tail test. What I'm trying to prove, average value, average marks is greater than 3.5. So I calculated a test statistics of 0.278. If my null hypothesis was true, right? Then I find out critical value. Critical value I find out at 1.7. Critical value is nothing but this in a right tail test, this number in this number line, right? So this number when I put it is 1.7. If my this test statistics what we have calculated is right side of this critical value, right? I could have rejected my null hypothesis, right? So if rather than 3.6, let's say I would have got 5.6, right? Then what would have happened? So if I go back to the formula, what would have happened? 5.6 minus 3.5, that is 2.1. 2.1 divided by 0.359. What would have been the answer? 2.1. Other parameters remaining same, 0.359. I would have got a result of 5.849. 5.849, right? So in that case, what would have happened? I found a critical value of 1.7, but the test statistics I'm getting as 5.84. That means test statistics lies to the right side of your critical value. Then you can reject the null hypothesis. Try to understand it the way we discussed. If I take a quiz of 30 students and I'm getting a average marks of 5.6, do you think that your population quiz marks will be less than equal to 3.5? If I telling that okay, my sample is a representative of population, I've done all the randomization and everything, and with that if I get a score of 5.6 out of 6, then what actually is that? Actually the population average also would have been greater than 3.5. Yes or no?
Yes,
If I
sir.
right, and that is same thing I want to study here. So what I'm doing here, so I'm trying to find out if my null hypothesis is true. That means if average kind of quiz marks was less than or equal to 3.5, what would have been my critical value? What would have been the line which would have said below that null hypothesis is accepted, above that null hypothesis would have been rejected. So I find out that as 1.7, but when I calculate that I get a number of 5.8, then I could have rejected. But in this particular case, what has happened? So when I go and calculate, so I get a number of 0.278. 3.6 is obviously greater than 3.5, but I'm trying to predict or I'm trying to hypothesize for my population. So when I do that, I get a number of 0.278. So and when I look that here in this number line, so 1.7 what line 1.7, which is the point which separates rejection and non-rejection region. And when I look at 0.278, where does it will lie? It will lie close to this 0. Center value is 0. So it will lie in this white region, right? Then I will not be able to reject the null hypothesis. So main point is if I get a sample quiz mark of 3.6, I'm not able to say that yes, the population quiz marks, or if I do it for 350 students, the average quiz marks will be greater than 3.5. With this data, I cannot claim that. But if I've got a average quiz marks of 5.6, I could have easily told that, right? That yes, because the test statistics what I'm getting would have been greater than my critical value, right? So this is how you carry out a hypothesis testing, and there are different ways. There are different tests to carry out, but the fundamentals remain same. What kind of error? What is your confidence level? Confidence interval? Don't worry about the calculation. Again, when you do the one sample t-test, I'll go one by one step. If you do not understand it, also it is okay. But from today's class, what I want you to take from today's class is alpha, that is level of significance, confidence level, confidence interval, then how you actually find out this critical value, right? How you actually find out this critical value. Then once we start doing that, then we'll be able to understand it, how to calculate that. Remember actually how we want to, what actually is our like objective. I'm taking a sample and I'm trying to predict for a population. If my null hypothesis is true, whether this kind of sample I'm actually will get. If I say that average quiz marks is less than 3.5, but I'm getting an answer of this 30 student, I get a quiz mark of 5.6. It will be very rare, right? So that's what I'm telling. If average quiz marks of 350 student is less than 3.5, getting a sample 30 student randomly, and if I give a quiz and they're scoring 5.6, it will be a very rare event. I'm not telling it will impossible, but it will happen rarely. That randomly I choose students and all of them are class toppers. Then only it might happen that they get average score of 5.6. But that is a rare event that I am accepting. But if I get a quiz of 3.64, that means it might be possible that the average quiz marks is less than equal to 3.5, not greater than 3.5. Right.